Hello, hello. Good morning, good afternoon, and good evening, everyone. Thank you for joining us today. We will be getting started very soon. Before we get begin, I love to hear where everyone is joining from today. Feel free to drop your location in the chat. I am Bing. I'm joining from Sacramento in California. It's summer here, of course. We're supposed to get a 95-degree, but now it's 60, which is very nice. How about you guys, our speaker today? How about Chris? How about you?
I'm in Oklahoma City right now, and it's about 80. I think it's supposed to get up to about 90. So it's trying to decide if it wants to be summer. Arun?
I am in a small village in the Himalayas, and there's a storm which just passed over. So hopefully the net stays up. It should. And it's 25 degrees centigrade. You might have to do the calculation to find it. Sorry.
Nice. How about you, Morphe?
Yeah, I'm joining from Helsinki, Finland. So the weather here is very good. I believe Finland have a best summer in the world. So the temperature is right now is around 18 degrees, which is very comfortable. Yeah.
Nice. Oh, we also have Jim said the Southern California on the cooler than Sacramento. Yeah, so I'm always jealous of us, you guys' weather. Yeah. Always you see, our audience and our speakers. It's such a global audience group. So nice. Alrighty. Okay, let's get started. How to build election data maps with precise boundaries and AIs. Hi, everyone. Welcome. I am Bing. I'm the product marketing manager at Mapbox, and I will be your host today. We are very excited to have our speakers today. They are Chris Beyer, product manager at Search at Mapbox. And then we also have Arun from our data engineer team at Search and Mapbox. We're also very excited to have Morphe from Location AI at Mapbox join us today. Arun and Morphe is going to show you a very exciting kind of AI demo today. All right, our agenda. We're going to talk about modern election mapping challenges. If you remember, if you joined here 2 years ago, we hosted a similar topic, but now, AI and all the AI tooling. So we have a lot new tech stack and new content to share with you. And we're going to share some customer use case and examples for election mapping. And Chris also talk about what boundaries and location AI and Mapbox. And then we move to two very exciting demo time. One is Aru's going to show build customizable election maps in 10 minutes with AI. You will see the live result within 10 minutes. And the second demo, Morphe is going to talk about geospatial analysis with AI. When we talk about mapping, you cannot avoid talking about data analytics because a lot of the data analytics are all behind the things. And then we're going to show a quick demo about the Mapshot API we just launched in private preview recently. And the end, we're going to open for Q&A. So feel free to drop your questions, submit your questions through the Zoom Q&A features. And also, captions are available in multiple languages. All right, Chris, without further ado, I'm hand over to you.
All right, awesome. So when we're thinking about maps in general, but election maps in particular, mostly we're thinking about this final result. It's a beautiful visualization. The user can dive in and look at details and things like that. But to be able to build an experience like that, you actually have to have excellent data. That data has to be complete, has to be correct, and it has to be both fast enough to be able to handle all of the interactions that are going to be coming in, as well as complete enough to be able to handle all of the analytics that are going to be coming out. So it's a very complex type of interaction that you're actually building here. It's not just a visualization. It's data that's giving you an answer, and that can be built in a way that can give you an answer. You can go to the next. So when we think about building election data maps, and honestly, any map, uh, the one of the most important things you can have is high quality data. And that goes into like how complete is that data? Like, does it have all the things it's supposed to have? But also, how correct is that data? Does it have gaps between the polygons? Does it have overlaps? Does it have issues within the metadata itself? So, like, if something is incorrectly marked or misspelled within the data, you're going to have problems with the outgoing analytics. And then for any map, but especially election maps, you have time pressure. I think in the US right now, we have several states that are still redistricting, even though we're going to have major elections this year. So those we're going to have to get into our product before things happen. And then that's going to have to be implemented by folks before the elections happen. So there's always a time pressure. And then for data intelligence, how does that data connect between the different types of information that you want to expose to the user? So, in other words, can we connect it to demographics information or access ability for an election, or say like voter districts and registrations? We know what percentage of that population is actually going to vote. And finally, we have visualization, the output. Uh, for that, you need a beautiful map, not just a correct map, but a beautiful map. And I've seen a lot of maps that are very highly accurate, but ugly. So you really want both sides of that coin. You have to have good data, correct data, accurate data, and then data that really looks good when you're showing it to the user. So luckily, Mapbox actually has all of those things. If you're wanting to build data with, say, geographic boundaries, administrative boundaries, legislative boundaries, those sorts of things, we have that as a part of the Mapbox Boundaries product, which we're going to be showing you today with the Runes demo. These maps are very fast and very scalable. And we have a lot of templates that you can just kind of plug and play into your implementation so that you can get going. In fact, I think Arun's demo today, we should be able to grab that once we're done and build your own implementation of that. Isochrones also are super cool. So this is pretty relevant to an election mapping use case. You can look at how far on the map you can drive based on an amount of time, which that's important for election access. So if you're doing additional analysis on, say, for this particular region, how far does someone have to drive in order to reach a place to vote? And what does that look like when you're visualizing it? That's a great solution for that. And then lastly, we have our location AI tools, which we're going to be talking about with both Arun and Mofe here today. So one of our friends over at the New York Times have done us the grace of using our platform for their election mapping quite a few times over the years. This is the map from the 2020 election where they've used boundaries as well as the Mapbox platform to build an amazing map and an amazing experience. It lets you dive into very detailed results on the election and also brings in a lot of demographic information, a lot of other details, plus a geocoder that lets you search and find where things are happening. So this is super cool, and I highly recommend if you are building election maps, go out and check this out because it's a really cool implementation. Go on next. So when we're building data and we're building solutions, we're not just thinking about one particular use case. Boundaries can be used for a lot of different stuff, and that's including like BI and analytics. You can tag data. You can even think about this in the election side of things. If you have residential addresses, you could tag those to the legislative districts using the data. So you can do more aggregations and that sort of thing. Territory planning is more like a sales area planning operation. And then you can also think of it for like service coverage where people are coming on to signups and you have areas that are given to particular contractors or service providers. And then lastly, of course, the data is beautiful for visualization. So if you're wanting to build a beautiful map, we can help you out. Another thing that's important here is the format of the data. So generally speaking, most folks think of Mapbox tile sets. They're great for doing really fast interactive maps. And they're really easy to implement. Just like a few lines of code, you can bring in a tile set and then build some joins to be able to visualize data using that. But we also have a new format for flat file data. And this is like actually really important if you're doing any kind of geospatial analysis. So if you're combining data sets, let's say voting districts with legislative areas, or if you're taking point and polygon analysis with residential locations or polling place locations, and being able to tag those or run those through an ETL with the flat file data, it's almost imperative that you have the raw data to be able to do that. So from our customer side, we had a couple of really awesome quotes from our customers where they're saying that they increased the performance of their maps by like 50% by running them through with boundaries because they're so dang fast. And they've also had higher engagement by 58%. Pyramid, one of our BI customers, actually integrated this with their own Gen BI or Gen AI platform to be able to answer questions for customers, which is actually something we're going to talk about here in just a little bit when we get into MoFace demo. Go on to the next. We've also just recently released MCP tools. So I know there's a lot of folks these days that are getting into the whole vibe coding or AI assisted coding agents. And Mapbox has recently put out some stuff to help use our services, our platform with those AI coding tools, including the ability to do, say, global geocoding with a request, or travel time matrices, or static images, being able to incorporate that. And we also have agent skills built into this. So it can be used with like Claude Code, Cursor, Copilot. So you can use it to perform tasks more effectively. Um, then we have the Mapshot API, which we're going to demo here a little bit later, which is super cool because it really you can look at the map, ask a question about it, and then get a response based on what's on the map, which I just think is really cool. Uh, so if you're interested in checking out the boundaries data, we've got the Boundaries Data Explorer that's up on the net here, and there's a link to it. We can provide it afterwards. We basically have our entire data set up there for you to peruse, see what the coverage looks like, what the quality looks like, and whether it fits your use case and your purpose. And then on the AI side, we also have documentation up for getting started with location AI, be able to check out what our tools look like, MCP servers, and whatnot. And now it's time for the actual cool part of the presentation, where I'm going to pass it over to my esteemed colleague, Arun, to show off how this stuff actually works.
Thank you, Chris. Hey everyone, my name is Arun Ganesh. I'm an engineer in the Boundaries team, and in 10 minutes, we have 10 minutes, we're going to show how to actually build something with boundaries, and we're going to make a interactive election map with some open data and Mapbox boundaries, and with the magic of LLMs that we have today. So right into it. What you're seeing is my terminal with Claude Code open. And this is what I'm going to use as the input. A prompt. It says in a new folder, build whatever is there in this prompt document. And let's go. Okay, so while Claude does all of that, let me show you what's going to be happening. And then at the end of this webinar, let's see what it actually builds. We don't know. So it's going to be a live experiment that we're doing here. Let's see. Okay, so when you look at maps, as Chris mentioned, there's a lot of inputs that go into making an interactive map. And one of the hardest parts with making a map is there are multiple components and they all have to talk to each other, especially the data. So if let's look at uh, an existing map. So this is a web search for a US historical election map, and let's see the top result that's here. And this is the top result for a historical US election map. And it looks like this, which looks like a series of static images which show party-wise breakdown of results. Great. Uh, but if you want to see things in more detail, it gets a lot more harder. So what we're going to do, and what the prompt is doing, is actually building an interactive version of this. What it's going to look like at the end, we'll just show that so you have an idea. of what the same prompt built before. This is what the prompt had built. And let's look at it. So this is a Mapbox GL map, fully zoomable. It has a time slider with which you can scrub through different years and see the results for each year, along with some statistics for each election. You click on a state, and you also get to see a zoomed in view of the state with details from that state. So this is what the prompt built in 10 minutes before. So this is what we have up and running as the output. What the prompt I started off now will generate another output with the same prompt, which might be similar, but not exactly, which is how LLMs work. Meanwhile, let me show you all the components that went into the prompt so you have a good idea of what went into the prompt and what are the inputs to create an output like this. So let's start with what was the input into the prompt? What kind of data sets or data do you need? So this is a single folder which had all the inputs for the prompt. And this is the input data. So obviously you need some election data, which I've got here, some info about the candidates, and some geographic information which has come from Mapbox boundaries. Now, the interesting part of this is if you look at the size of the input files, you can see the election data is probably the biggest file, half an MB, and the rest of the files are really small. And the prompt is also a very small file. So this is the inputs you're giving it. There's no shape files, there's no large databases that you're working with. These are the inputs. So really compact. Uh, and the true magic is what tools like LLM and Claude can do, which is you give the most basic input with the correct definition and the instructions, and it knows how to build, it knows how to documentation, the Mapbox documentation, and build a fully interactive web application like what we're seeing here. Okay, so these are the inputs. Let's look at each file in more detail. Let's also look at our prompt. Oh, so Claude is asking me to proceed. Yes, and don't ask me again. Okay, I should have checked this earlier. So this would have been running much more. So it was waiting for me to say yes. Okay, meanwhile, we'll still go through all the files. This was the prompt directory. And let's look at the prompt. This was the prompt itself. And I'll go through it from top to bottom. So the whole prompt is probably a page or page and a half long. And it starts really simple, top level, create a US presidential election map using the data that's been provided. Use the Mapbox boundaries for the US state boundaries. So this is our geographic data that we're giving it. Of course, instead of state boundaries, we can use some other kind of boundaries like legislative boundaries, congressional district. You just need to ensure that the data you have matches the sort of geographic reference. So you have actual data to join with congressional district boundaries. In this case, we found open data, which we can easily, instantly join with the state boundaries, which is why we're using the state boundaries vector tile set. I've given my Mapbox token to build this. This is a temporary token that I've created just for this particular demo. So it won't work anywhere else. And for anyone who's not done that, it's quite easy in the Mapbox console to create a new token and to lock the token into a particular URL. So this is going to run just on my local host machine. And then I'm defining how I want my user experience of the map. So map should shade each state by the winning party and the vote share. You want a time slider to select the year. You want an information pane which shows a US level and a state level result. and some fancy stuff like vote swing meter and percentage of voters who switched, bar graph, and a few things. And this really helps narrow down the scope of what Claude does. So the more specific you are in what you want the final map to look like, the better the output of the LLM. So I'm going to look into my prompt again. It's still running. It's been running for close to 3 minutes. Claude is saying it has everything it needs. Excellent. So now and then just keep checking if it's going well. It should, as you have seen in the previous output. Okay, let's go back to our files. So this is some really interesting UX behavior. So I mentioned here the map legend should be interactive. So instead of a static legend, make an interactive legend with which you can actually filter the map. And I can show you what this means here. So this is a legend, but here I want to see only the states where the Democratic Party won or the Republican Party won, or show by the minimum winner share. So all these sort of interesting ways to slice and dice the data, explore the data, which otherwise without LLMs would take a lot of effort to code. Uh, you give the correct instructions to LLM and it'll do it for you. The Okay, so here's another interesting feature we've added. In addition to polygons, also add circles for every state and scale the circles by the number of votes for the state. And here you can see that it's added a circle. And the reason why these are useful in maps is usually when you have something like an election map, you see the bigger states visually more clearly because they're big, like Texas, for instance. But smaller places like DC would get hidden just because they are smaller in geographic size. And adding a point like this makes sure that small areas do not get hidden. So it's a really neat little cartographic trick, and you're just giving us simple instructions. And let Claude figure it out. You've given it link to the Mapbox docs, which tells you how to use the vector tile sets, where the centroid points, what are the attributes available, what happens when you click on a particular state, and a little more about the input data sources. So this is the historical US election data. This is open data that has come from Harvard Dataverse. Then you have the Mapbox boundaries data. Uh, and the input from Mapbox boundaries is a lookup file, which is this. So unlike traditional map making, no GeoJSON, no uh, huge shapefile, a simple CSV, which essentially tells, okay, this is a state name, the state code, and the feature ID in the Mapbox vector tiles for the state. That's all you're giving it. And the LLM will figure out how to join it up in the Mapbox GL interface. And another interesting thing we have done here is bring in Wikipedia and Wikidata. So this is another third-party database, and we're going to be using Wikidata to bring in the photographs for the candidates and to create this interesting visual experience where you have photos for every candidate. And after that, you have a slightly more technical build instructions, which instead of Claude getting confused of which tool to use, you're straight away telling use some libraries. So this was done by giving Claude the first prompt and then asking Claude itself, help me improve the prompt. And this section was added by Claude's suggestion itself. So it was this part that I wrote by myself. So this was human written. And this part, Claude itself improved the prompt in a later run. So let's see, you have Claude running. It's still finish, and we let it run. And at the end of the webinar, after more phase demo, let's see what it's built. Off to you.
Yeah, hi. This is Murphy from Location AI team. Today I will to show two use cases that I use AI with boundary data and use AI to analyze our map data. So for the first demo, I just let's assume you are the sales manager, and you are trying to have this kind of data. Let me share my screen very quick. Yes, if you are a sales manager and you are export this kind of data from your system, in the data, you will have this account ID and the status code for each account, and also the sales data uh, for each account. In the old time, if you do this without LM, if you want to make this kind of page, trying to summarize which stats have how many sales data, I believe you have to write some code to work through this data, and you have to build this map from scratch, and it could take maybe half a day, or if you're not familiar with Mapbox technologies, maybe it takes longer, for example, 1 day or 2 days. But right now, as Arun showed, if we use LLM with some certain prompt, you can build this kind of page very quick, maybe in 10 minutes, maybe less than 10 minutes. But then let me build on the top of it. For example, if you are already have this page and you want to show this page to your colleges, and your college is asking, can you show the data by territory? And if you want to do so, maybe in the other way you have to do the process I described again. But right now, with Cloud Code, you can have this kind of prompt. So the prompt is very important, but since I already described some of that, I will just go through this prompt very quick. So in this prompt, we just tell the cover code what is our system and what is our task and what kind of data we have. Here you can see we have this sales region data, which looks like this. For each regions, we have different stats. And that's all. And we also need to define some rules for our code agent. If we copy and paste this to color code, let's see what will happen. So after this, I believe color code is trying to read the files and to analyze the data and to combine all the data with our boundary metadata. For example, this one. For this kind of Mapbox ID, if you purchase our boundary tile set, you will get this kind of CSV files, which I will already show. So let's say, here the cloud already generated this kind of code. Remember in here, I didn't ask the cloud code to put the code back to the files. I just trying to demonstrate it. So I asked cloud code to directly output this. Let's verify it in the browser. For example, I can, this is the same result. I can copy the result on here, then go to the browser and run it. See, it works. So just with one prompt and maybe around 2 minutes, it can be done. Actually, I have the other three prompts, but I will not go through them one by one today. I just want to show the final demo very quick. So this is our final demo. This is a static demo at this moment. But from Mapbox location AI team, we have another service we call Mapbox Location Agent, which we have the backend engine to analyze the data on the backend and to control the map in the real time. But here, just to show these demos, for example, for the first one, it's very familiar. We just done this already. And also, your colleagues would maybe asking, can you filter the data? Of course, the agents are good at this kind of filter. So it's showing the southwest. And of course, we can, if we are not interested with these two regions, we can remove it. And if you want to add one more regions, you can add it as well. And of course, you can filter them by the revenue. So the agent could analyze data as what you described. And of course, the most interesting thing is we want to compare to get the top sales. From here, you can see if we ask the agent to show the top file enterprise, it can show here. So basically, all of this happening similar with what I'm doing here, but in the real product, we have a backend agent to host everything. So this is very quick demo for the first one. I think it's very overlapped with what I was trying to show. But what next I want to show is something I think is really amazing. Because right now you can see the agent, the AI could trying to understand your data, could build the map, but could AI really read your map? This is something interesting. So let's say this map shot demo. So what is map shot? We are right now building another API we call map shot. For map shot is kind of a backend agent. When people trying to communicate with map shot, they will need to send the style ID and also with a query, and our backend agent will try to rendering the map on the backend and answer your questions based on that. So let's try it very quick. This map is just from what I done previously, and I already converted to the style here. And now let's try some questions. For example, this one, I'm trying to ask him which part contributes more sales data, the West Coast or the East Coast. Then I send these messages to our Mapshot API. Our Mapshot API will trying to do rendering and understanding the map. And from here, you can see we don't send the rendering image to the backend. We just send the style ID and the coordinates and some other queries. Yeah, and the Mapshot API can tell us the East Coast contribute significantly more total sales. So what's important is we don't send any legends to the backend. So the backend can really read these images and answer the questions. Let's try another one more time. I want to compare these two states, Texas or New Mexico, to see which one has better sales. Let's say, yeah. So the agent says Texas sells significantly more data, more than New Mexico. So yeah, so basically from now on, you can say our agent can really understand the map. But after this, I want to show some my favorite examples here. Our Mapshot API can also understand the satellite image. This is somewhere in Helsinki. Let's image if you are outside for dinner and you are thinking about whether you should go to a swimming and is this a good place for swimming after dinner? You can set this kind of questions to the Mapshot API. The Mapshot API will try to load this image and try to analyze to actually see the map, to read the map, whether there is a swimming pool or not. From here, we can see we have two swimming pools. And the answer is yes, this is a good place for swimming after dinner. But let's do something crazy. Let's move to somewhere like here. It looks like swimming pool, but it's actually a square. If we send the STEM questions, what is the answer from the agents? Let's see. And the agent is thinking, yeah. The agent realized this is not a swimming pool. It's just a square, and you can definitely not go to swimming here. And also, of course, the agent could understand the location and it have some suggestion for you where you can go for swimming. And the second, and the other demo is also something very useful for me. I mean, for someone who want to buy an apartment. For example, if you are trying to look for apartment, if you are looking at a normal map like this, it sometimes could misleading you. For example, from here you can see there are some seaside, there are some green areas, there are some highways, etc. So you may get a result. Oh, this is a good place for apartment. But unless you read the satellite image, you will change your mind. For example, this time I sent this satellite image to our map shot. Here in this demo, I just running this in the front to demonstrate that. But in our real API, we don't need to send this image to the backend. The backend could load that from our image styles. Let's say how the agent will answer these questions. Is it a good place to buy an apartment? That's three. Yeah. Results come out. Yeah. So it tells us no, this is not a good place for apartment, because there is some kind of industry area, etc. So this is a very useful situations also for me. And you can imagine if you have thousands of places you want to identify which one is best for you, the agent could give you your answer very quick. Yeah. Before I had this is the two demos I want to show. Before I hand it back to Arul, let me do some quick recap. So first, I showed the two examples. In the first one, we use AI to work with our boundary data and build a map much faster. And in the second demo, we used AI to understand what's on the map and answer questions about that. I think the interesting part is that AI is no longer generating maps or visualizations. It can also start to understanding maps and help people to get insight from them. Yeah, hopefully these two demos will give you some ideas about what we can do with AI and the map data. Yeah, thanks. Back to Arul.
I think we might
Thank
have
you, Morphe.
some time for a QA. Arun, did that prompt finish?
It did finish, so we can dive into what it did.
Okay,
Maybe
let's start with
we
that.
can- Okay, yeah, I'll start just showing what it did. Let's see. Okay, we'll just go through Claude. Yeah, it went through the files. It said very confidently it has everything it needs. It built the one single HTML file. It did some cleanup, very nice. Thank you, Claude. And then it tried to verify it loads by serving it locally. And this is where it seemed to have gone into trying to do something. So I just stopped it at that point of time. So because I can just serve it, I know how to serve it myself. I can show how to do that. So I stopped the process. Let's see how long Claude took. It took around 7 minutes to run that prompt, and it costed less than around $1. Let's look at the output. So this, it created a new folder called build. Let me go into that folder. And I am just going to serve that folder locally. And here you go. So I literally did not touch anything or do anything, but this is what it's built. Let's see if it works. Yeah, it seems to be working. I don't see the state labels. Okay, yeah, state labels are showing up. Yeah, by and far it looks, yeah, you have the interactive filtering of the legends. Yeah, just like the prompt. There you go.
Awesome.
Very cool. Thank you. All right. I think now we have a couple questions I think in the chat and some question in the Q&A. Chris wanted to take over the questions.
Sure. So I saw a question from Ron to Mofe about are the outputs for Mofe's websites a single HTML file or large directory structures?
Right now, what I'm showing is directories, so it's not a single HTML files. But you can ask the Cloud Code to combine all the JS, CSS, or HTML into one file. but that is not a best practice. Yeah.
Okay. Right. And then on the Q&A side, are there any plans for Mapshot to take into account values in custom geodata attribute tables in addition to what it sees on the map, i.e., a point of interest layer with details about that point of interest in the data itself?
Yeah, I think this is actually a very good questions. So right now the map shot was under the preview review process. So we are actively collect the feedback from the customers. And for the next steps, we are consideration to, for example, to let our map shot agent to collect more data. So some data can be from our dataset itself, and some data maybe could come from the customers, but we will really need to review the feedback based on this. Yeah.
That's cool. And this is a question from me, but if we have the POI say in that tile set and we have the ID that's associated with the search data, the metadata that's associated with that POI, would we be able to traverse that and actually pull some of that detailed metadata out as well?
Yeah, so this is a very good questions. Actually, we are doing some researches whether we can collect more data from different layers like PORs, etc. So this is on the so we are doing more and more researches, and I think we will get more better result after that. Yeah.
Okay, awesome. Sorry, I get excited about this stuff too. Let's see. Oh, on the election boundaries side, there's a question about how granular the boundaries can get for election mapping. And so that actually depends on what region we're talking about. In the US, we provide, as part of the boundaries data set, the state and federal congressional and Senate districts that are part of that. We don't go down to the voting district level, which is like, if the area in which is going to contain your polling place. So we don't provide that, but we do have like the usual states, counties, plus legislative districts. And then globally, kind of varies depending on the region, how those elections are managed. Some places just use the standard administrative areas to manage elections. Others have custom legislative boundaries. If you go to the Boundaries Explorer, you'll be able to see all the detail on what's covered and where. Okay. I have another question about Claude and MCP server. Can you talk a little bit about how workflows might be allocated between Claude and Mapbox MCP server, etc.? I'm not sure if this one's going to go to Arun or Mofe. Might be collaborative.
I can answer it. For me, Mapbox MCP server is kind of a protocol or some kind of tools for cloud. So when cloud want to get the specific questions, like if the cloud code want to get the POI information, or if a cloud code want to get the navigation information, etc., the cloud code could use Mapbox MCP service to fetch our API and to get the data. So which means you can imagine the cloud code is cloud, or any AI agent is kind of client, and our MCP is kind of describe how the client can communicate with Mapbox APIs and to get the data. Yeah.
All right. Question about boundaries again. Can we show election results of counties, as in local government, and are the boundaries maps available? Yes. For the boundaries data set includes, that would be, I think, the admin 2 data set for the US. That includes all the county information, and then that has its equivalents globally. You would be able to do, say, aggregations to that, and those, it's part of the boundaries data set. You'd be able to join that up to it. So if you're looking at the county commissioner results or local election results, that kind of thing, you'd be able to display those there. Okay.
That's a couple questions people always ask. Can we get the recording? Yes. So we will be sending out the recording, the material, some additional resource early next week. So check your email. Thank you.
Another boundaries question. So how does the Mapbox boundary data differ from open source boundaries datasets? Um, so I guess the biggest difference is it's all in one place. So for a lot of different types of boundaries, you're going to have to go out and find the right source for that particular boundary, especially globally, internationally. A lot of things live in a lot of different places. You're going to have to go grab them, or in the case of like postal boundaries, you're going to have to actually create them in some cases because they don't really exist as a standard boundary feature. Versus the way that Mapbox does it, we create those boundaries or use those sources and then we clean them up. So the other thing that's different is the output quality. We go through a lot of topology corrections, for instance, that make sure that there's no gaps or overlaps between those polygons. And then we also make sure that the attribute information is clean, correct, and structured according to our standard process for metadata. And then we also create hierarchical joins between those. So, for instance, the counties have the ID associated with their parent state, is also associated with its parent country, and all the way up and down the line within those layer sets, so that you can actually create maps that are dynamic in terms of when you zoom in, certain features are going to be shown at your aggregation level or outside of it, going from the higher level hierarchy to the lower level hierarchy and so on. Those are the biggest differences. It's a lot of time savings because you don't have to go grab everything, and it's a lot of data cleaning and quality improvements. Okay, and then I think we might have already covered this question a little bit, but there was a question about whether we were going to be able to share the code samples from the election map demos shown during the webinar. Um, and then what should you as a developer expect for or consider when building scalable election mapping experiences? I think this is a question for Arun and possibly me.
In terms of the code samples, so we'll share the link of the demo we already have and the prompts as well, along with the input data files. It's all a very small package, so we can share this. In terms of building a scalable map, the hardest part to scale usually is the geographic map part because uh, you're going to be loading boundaries on the web browser and you want to optimize for performance, which means you need to generalize the boundaries. You don't have this problem with using vector tiles, where based on the zoom level, we provide optimized geometries for that particular zoom level. So as you zoom in, you get high precision boundaries up to the street level. So the geographic part is very easy to scale with the Mapbox boundaries vector tiles. And then it depends on the kind of data you're joining into those boundaries. So you might hit issues if you're trying to join all of the world's data at one go into those boundaries on a very granular level. But otherwise, for most use cases, there may be no issues. Usually, election data is in the form of a CSV, and even in this case, this is 3-4 decades of US presidential election data up to state level for every candidate, and was less than half an MB. So the payload is very small.
All right. Thank you, everyone. I think that's it. If you have any more questions, feel free to, always respond us to follow-up email as well. Thanks everyone for joining us today. We will be sharing follow-up like demos, materials, including all the additional resource after the sessions, probably early next week. Hope you all have a great rest of the day and hope to see you at our next webinar. Thank you. Thank you, our speakers. Thank you.
Thanks, everybody.